Hi, everyone. Thanks for coming. My name is Joel, and I don't like notebooks. So it's possible I'm the only person like this at the conference, but out in the no? All right, good. Because out in the real world, there are dozens of us, a few here. And so how did we end up here? Well, I was angry about notebooks. I tweeted that I wanted to give a talk about how I was angry about notebooks, and someone was listening, and it got accepted. And so, data science luminaries thought that it sounded like an unhelpful way to spend time, and I got lots of other positive feedback about it as well. But here we are. So what kind of person not only doesn't like notebooks, but goes to a conference about notebooks to talk about how he doesn't like notebooks? So I'm a research engineer at the Allen Institute for Artificial Intelligence. My job is Python, library design, and reproducible science. So I have lots of thoughts on these topics. I won't call myself a Python expert. You should never call yourself an expert. But I've been doing Python for a long time, and I have a lot of opinions about it. I was the chief data scientist at Volumetrics. I've managed data scientists. I've mentored data scientists. I wrote a popular book on data science. So I have some thoughts about how to teach data science as well. I worked as a software engineer at Google for a couple of years. And I work on Allen NLP, which is a very well-engineered project. I make live coding videos, so I think a lot about how do I teach concepts using code. I write a blog that's about Python sometimes, and I update it sometimes. And I co-host a data science podcast with Andrew Musselman called Adversarial Learning. If you're wondering why there's no episodes recently, that's my fault. I need to edit them. Okay, so that's me. I was going to start a timer, and I didn't. So let me start now.
Slow down too a little bit.
Too fast?
Breathe a little bit.
Oh, I have a lot of slides.
I know. Lunch is next. We'll stay.
Okay. Okay, so that's me. What do I assume about you? Well, you're at this conference, so possibly you think notebooks are great, and you came to this talk, so maybe you want me to change your mind. And so let me just give you a couple caveats. One is that I'm not a notebook expert. I've tried very hard not to misrepresent notebooks, but it's possible I may have done so inadvertently. If so, I apologize, but I have a lot of complaints, so even if one is wrong, they can't all be wrong. It's also the case that I believe there are probably advanced add-ins that might address some of my concerns, but they're obscure and I didn't know about them, and so that's why they're not here, but I apologize for not knowing about them. My other caveat is that there's a new product called Jupyter Lab. When I proposed this talk, it was not yet released, so I haven't used it very much. It's possible it addresses some of my concerns as well. It's likely it doesn't address all of them. Okay, so before I get into things I don't like about notebooks, to be fair, I want to talk about the things I do like about notebooks. So one is that I really love the literate programming model. I love well-documented code, and so I like the idea of mixing markdown and code. I find this a very nice aesthetic, and it's a great way of presenting things. Another thing I like about notebooks is that inline plots are pretty great. The story around plotting in the Python console is not a good story, and so I find this pretty nice. Okay, so those are the things I like about notebooks. Now let's get to the things that I don't like about notebooks. Okay, so this is my number one fundamental complaint is that notebooks have tons and tons of hidden state that's easy to screw up and difficult to reason about. So here's some very simple Python. I define a function f, takes a number x, returns x plus 2. I set y equals f of 2. I check, is y equal 4? Yes, it is. That's true. Print y. It's 4. Okay, very simple. Nothing fancy going on here. Here's that same example in a notebook. Define f, x plus 2. Y equals f of 2. Is y 4? False. Print y. Y is 5. Okay, so you're looking at that and you're thinking, if you look at the numbers, those cells weren't even executed in order. So, of course, it doesn't work. Okay, so let's go back and make sure that they're executed in order. Here 1 comes before 3, comes before 4, comes before 5, but still the same result. And if you look at the numbers, it's clear that something else was run between those first two lines, which is fair. But on one hand, you have this idea that notebooks are great for iterative development, but then you also have this idea that notebooks are actually kind of dangerous unless you run each cell exactly once in order, and otherwise you can't really rely on what the outputs of the cells are. So there's this tension there that makes me kind of uncomfortable, I guess. And some of you might be thinking that my preferred, REPL also has plenty of hidden state, which it does, but that state was built up in a linear fashion just by running one command at a time. And there is a history magic that I can put in a cell and see here's all the commands that have been run, but reasoning about state is actually one of the hardest parts of coding. And so we should make it as easy as possible, not as difficult as possible. So here's one more. This is not photoshopped. This is not me hacking the HTML. 1, 2, 3, 4 in order. What kind of trickery is this? Well, I just edited the first cell and didn't execute it, which I did on purpose to be deceptive. But you could do that by accident too, and really confuse yourself as well. So my next complaint is that notebooks are difficult for beginners. And so, someone comes to you and says, I would like to learn Python. And you say, okay, that's great, create a notebook and get going. Why do I think they're difficult for beginners? It's because these sorts of hidden state complications that I'm talking about are not obvious. So, this is most people's experience of how code works. You run a line of code, you run the next line of code, it happens in order. The ability to run code snippets in arbitrary order is actually really weird if you think about it, and it's very unintuitive. And if you look at beginner tutorials, they're really either cavalier about or completely silent on this hidden state issue. So I just did a Google search and found what I could find. So this is DataQuest Jupyter Notebooks for Beginners, a tutorial. So they talk about some cells and they say this will work regardless of the order of the cells in your notebook, which addresses the issue, but not this is dangerous, watch out, be careful, don't shoot yourself in the foot. And then later on they say most of the time the notebook will be top to bottom, but it's common to go back and make changes. In this case, just keep an eye on the numbers and see if you have stale output. And if your notebook is longer than a page or you can't hold 30 numbers in your head like that, then not sure. So this is a Jupyter Notebook tutorial, the definitive guide. It did not have anything about order for state. It was just stated differently. Hidden, nothing. Sequence, nothing. Enough rope to hang yourself, nothing. So it didn't seem to mention the issue. Here was the comprehensive beginner's guide to Jupyter Notebooks for data science and machine learning. It also did not seem to address the issue. So back to this example where I skipped cell 2. You people are all notebook experts, and so the problem here is kind of obvious to you. And also, this is a really simple example. Like, it couldn't be much simpler than this. For beginners who have dozens of cells and more complex code, this is utterly confusing, and I know this because they come to me with their problems. In fact, the original angry tweet that kind of launched this talk was the result of me helping someone who was new to Python and came to me and said, Python makes no sense, I don't understand it, it doesn't behave the way a programming language should, when what happened was Python worked exactly the way they expected it to, but they'd been very loose with state and execution out of order in their notebooks and ended up in a situation that appeared to make no sense. And this has happened to me multiple times. And you might be thinking lots of beginners use notebooks, so clearly it can't be that difficult. And it's not that it's insurmountably difficult, it's that the out of order execution makes learning Python more confusing than it needs to be. Okay, so my next complaint is that notebooks encourage bad habits. So you've got folders full of these, I've got folders full of these, everyone's got folders full of these. So there's this sense in the data science community, which I find super unfortunate, which is that data science code doesn't need to follow the rules of good software engineering. And this was, posed as a great tip, although apparently this was a misrepresentation of the tip, which I didn't learn until after I started a big Twitter fight over it. But if you take one thing away from my talk, it should be nothing to do with notebooks. It should be that data science code should follow the rules of good software engineering. And sometimes people will say, I don't need to be rigorous about my engineering because I'm just experimenting. Okay, well, experimenting is doing science. And to say I don't need to be rigorous because I'm doing science doesn't make much sense to me. Sometimes people will say, I just want to see if my model works before I put it in production. Well, and if you want to find out if it works, you need to write it correctly and make sure that your code is correct. Another line of thought here is that people will say, I need to write my code as fast as possible. And doing poor software engineering allows me to write my code as fast as possible. I don't agree that that's even true, but generally speaking, trying to write your code as fast as possible is great if you're doing a live coding presentation, perhaps. But it's not great when you're trying to do reproducible science and rigorous work. So having taken a broad tour of the Jupyter ecosystem, a really unfair, cynical take is that a lot of things that people build are to allow people not to have to develop good habits. You don't want to develop good habits, we'll build this for you. So this is just a blog post that came across my radar. I think I probably saw it on Twitter. It's just some random blog post, but Paco liked it, so there must be something to it. It's how to present your data science results in a Jupyter notebook the right way. And then it says how to import one Jupyter notebook into another. Okay, so here's someone who wrote some code, some function, and doesn't want their client or decision maker to see it. So they've invented a couple kinds of magic that allow this to happen. So it turns out here's some code I wrote, but I don't want my client to see, is actually a solved problem that people who do Python know how to do. But if you insist on putting everything in a notebook, then it's not a solved problem without this kind of thing. And in the comments, people actually pointed this out to the author and said, you should really just write modules and libraries and test them and be clean. And the author kind of admitted, I agree, that would be better than what I proposed here. But this takes into account that data scientists write bad code. And yes, this is hard to debug, I agree with you. But anyway, this blog post was called The Right Way. Okay, so notebooks encourage bad habits. They also discourage good habits. Here is some code from a live coding demonstration I do about building a deep learning library. On the left, you can see that I've nicely segregated things into modules. There's a loss module, there's an optimizers module, there's a tensor module. And on the right-hand side, you can see that I've used classes and inheritance. And I've made this code so that it's very clean and testable and reusable. And this is something that I live code in an hour. So it's hard for me to accept that it's too slow to do things this way. Okay, so how do we make sure our code works? We write tests for it. How do we make sure it keeps working after we make changes to it? We run those tests. Is it important that we use that kind of discipline when we're writing code to do science? Yeah, of course it is. And notebooks don't easily lend themselves to the kind of rigorous unit testing that you can get when you write things in terms of libraries, which is not to say that it's impossible to do, but it's not natural to do. Here's how I write code. I use lots of type hints, and I run MyPy to type check them. You probably don't write code this way, in part because I haven't lectured you about it enough. If you worked with me, you would have been lectured about it a lot. But also in part because notebooks, again, don't have a great story for using these type hints and checking them. So that's really tough for me. This is not like pie in the sky stuff. This is me. I live this. So I work on Allen NLP, which is a library for deep learning researchers. And we don't want people to do bad science with our library. So we test the hell out of it. We run type checking, we run linting, we run everything. And in our tutorials, we tell our users to write tests for their code as well. And this is something I strongly believe that tests are so important to doing good science. Okay, so my next complaint is that notebooks are way less helpful than my text editor. And some things are more easily demonstrated. So let me show you. So I use VS Code. And so I define x's equals 1, 2, 3, and now I want to insert something. So I do x's, and I get this autocomplete that nicely pops up, and I do insert, and it says, okay, 0 is my index, now 10 is object, so that's fantastic. So now if I go and do the same thing over in my notebook, well, to start with, if I do x's equals 1, 2, 3, and then trying to do tab completion, nothing happens because I have to do it in different cells. So, okay, now if I run it and I do x's, I get the completes, but they don't have that extra information. And if I do insert, that doesn't do anything. And so if I want to get help, I can run that, and now I get the help. But it took me a couple of extra steps, and now I have sort of this mark of shame that I had to use a question mark. And if I delete it, then suddenly I get cells that are out of order. But if I leave it there, everyone knows I didn't know how to use insert. So I'm sort of in a little bit of a bind. This one is just kind of silly, but I want to compute the cost of my van pool. So I'll say it has 10 riders and cost equals van pool riders times 50. Okay, that's reasonable enough. So let's go over here and do van pool riders equals 10. That's good. So now if we do cost equals van, and I want to do tab completion, for some reason the tab completion seems to favor all the files in the directory over, and it's possible that I might want to use a file name as my variable name, but it's sort of unlikely. The next one, which is a little bit tougher, so like I said, I used to use type hints. So from typing import list, and I have some function def f, let's take it y's, which is a list of strings, and it will return none. And so one of the joys of using type hints is that now I can get this kind of autocomplete on this variable just because I've told my editor this is a list, so now you can give me things like that. So in a notebook, because, let's do typing import list. Because you have to execute a cell before you can do that, as far as I can tell, and I may be wrong, but I can figure out a way to do it, it is impossible to get that kind of tab completion. And so you're thinking, okay, I don't use those kind of type hints, which you probably don't, because only I do. But here's one thing that you probably do use. So, file.text as f dot, and now here I get autocomplete on all my nice file commands. Whereas if I try to do the same thing over here, I got nothing. So that's just a way in that my editor is a lot more helpful to me than working in a notebook is. And that's kind of a small frustration, but it's kind of integral to the way that I do my work. So these are just slides that I have showing the same things in case it didn't work, but I'll just skip past them. Okay, so there is an extension called Hinterland that I found that does some of these autocomplete type things. But some of its autocomplete behavior is kind of questionable, and it still can only autocomplete things that have been executed, which means it still can't handle these type hints or the with blocks that I showed you. The other thing is that my editor has an integrated linter. So if I do something mistaken, like, hey, I forgot to use one of my variables, it will underline it and say, hey, by the way, you forgot to use this variable. You probably did something wrong. I couldn't figure out a way to get that kind of feature in a notebook. I did, look, is there a way that I can run some kind of linting on my notebook? And there was one solution that I could install this and use a %% pep8 cell magic for each cell. And then there was another one where I could install PyCode style magic and do %% PyCode style for each cell. And then there was another one where I could do these other things. But anyway, whatever it is, it's a lot of friction, and it didn't get me the same feature that I get in my IDE, which is what helps me be productive and write good code. And it's possible that some of these things are addressed in the next generation Jupyter lab, but in the version I tried, this is what happens when I tried to do tab completion in the text editor, and so it didn't do what I wanted either. So my next complaint is that notebooks encourage bad processes. So I saw this on Twitter fairly recently. Jupyter notebooks can now share kernels within Jupyter labs. Makes it easy to share state between notebooks. So this is fantastic. And I tried very... I tried very hard to think if I could come up with a non-evil application of this functionality, and I was not able to. But so it may just be kind of above my pay grade, because I have the small brain where I have to run commands in order in the console, and then you might be a little bit more enlightened and run commands out of order in a notebook, but then you need the cosmic brain to run commands in indeterminate order across multiple notebooks. So once everyone knew that I was writing this talk, they started coming to me with their Jupyter problems and said, you don't like Jupyter, you must know a lot about notebooks, tell me how to solve my problem. So here's someone who said, when I have a huge data set, I'm used to saving time by just keeping it in memory in my notebook, and then running different analyses off of it. And I asked, why don't you just persist the process data? That seems sort of safer and more replicable than having it hang around in memory. And he seemed to agree that that was a pretty good solution. Okay, so this one you will find probably controversial. Notebooks hinder reproducible and extensible science. And yeah, I'm serious. So don't take it from me, take it from Francois Chalet, but don't tell him that I quoted him on this because he probably doesn't agree with me about notebooks. Poorly factored code is bad science, hinders reproducibility, increases chances of a mistake. Notebooks are a recipe for poorly factored code. Okay, so this is an idea that my coworkers and I were kicking around at lunch fairly recently. And we thought we could use a neural network to generate some music. And there was more to it, but this was kind of at the core. And so I thought, I don't want to reinvent the wheel. Let me find someone else who's done this. And I use PyTorch, so I said, let's find a library that does MIDI in PyTorch. And so there's the first result. They've got a GitHub repo, so I'll go check it out. And so, I go there, and all I see is a notebooks folder. I was hoping there'd be a model.py or a models.py or something that I could look at and get a sense of how the model works. But they actually have just a notebook that trains their model. So, I go there, and they got a bunch of imports. Is it PyTorch 0.3, 0.4, 0.4, 0.1? I don't know. I can guess based on the commit date, but it doesn't say. And just as an aside, I went to look, is there a good story around managing requirements for notebooks? I couldn't find one, but someone helpfully on Stack Overflow said that good libraries are written to be backwards compatible, so ideally any version should do. I downloaded that answer. Okay, so this is the code for training the model that I found. So, in one cell they've got model definition. In the next cell they've got model instantiation with some hard-coded parameters. Then lower in that cell they've got more parameters. In the next cell they've got some hard-coded paths. Then further down there's more parameters. And then finally a training loop. So this code is pretty much impossible for me to use. First I have to look at the notebooks, manually install all the dependencies, and hope that I got the right version. Then either I can run it the exact same way on the exact same data, the exact same paths, or I can copy the notebook and try and figure out how to modify it, which forces me to work in a notebook, or I can do a lot of work to copy and paste the right parts into a module that I can import into my own code. And yes, there is a tool called nbconvert, and that does get the code out of the notebook, but it still mixes the library code and the execution code. I still have to go through and line by line figure out which parts I need to change and customize. Still no requirements or tests, and still a few comments. And so I want to be fair. This is someone's fun project, and so good for them for sharing what they did. I don't want to look down on them for sharing what they did. I think they probably thought they were being helpful by providing notebooks. But what they did was make it sort of possible, but not easy, for me to repeat their exact same code with their exact same data at their exact same paths, and if I have all the right dependencies, and making it very hard for me to build new things on top of their code. And lots of non-notebook code has these same issues. But notebooks sort of implicitly encourage this workflow. But you can imagine an alternative, a requirements.txt that indicates here's exactly the dependencies you need, a clean parameterizable load data module, and a clean parameterizable model with good documentation and unit tests. An easy way to programmatically specify all the model parameters and so on, and a script that replicates exactly the original result that can be tweaked in obvious ways to run novel variants. And so this is what we do on my team at work. This is the code for producing Elmo, which is a kind of contextual word embeddings that one of my colleagues came up with. And so the installation instruction says, run pip install this exact thing, run python setup.py install, and then run the tests. And then when you want to train your own language model, here's the command to run. It's very obvious where to put in your own parameters. And if you want to go and start creating your own variations, it's very easy to look at the code and make those modifications and obvious where. My next complaint is that notebooks make it hard to collaborate across media. So what do I mean by this? Imagine PyTorch Slack beginner channel. I'm a beginner, so that's where I hang out. Someone asked a question, I don't understand why my code's not working. I understand why his code's not working, so I want to help. You've done something wrong. Let me create a really minimal reproduction that shows you exactly where you went astray. So I did it, I copied and pasted it, and I explained it. And you could say, it probably took you a few tries to get that code exactly right. I bet a notebook would have made it easier. Okay, so I can do that. So I go to a notebook and I do the same code and it works the same. But now I need to copy and paste it into Slack. And that turned out to be more difficult than I was expecting. I tried select all copy paste. That got me a bunch of headers and other stuff. I tried select cells, edit, copy cells, paste, which didn't seem to do anything. I did select cells, copy paste. That got the inputs but not the outputs, which made it hard to illustrate. So basically, I could not figure out how do I copy and paste code and outputs from a notebook into Slack. And as far as I can tell in Jupyter Lab, the things I tried that made ugly versions wouldn't work at all. So This might seem like a frivolous complaint, but I actually spend, as my job, a lot of time debugging people's Python issues with Slack. And similarly, I spend a lot of time pasting code into GitHub issues and code reviews. And so making it impossible for me to do that is kind of a non-starter for me. One other nuisance, if I do kernel restart and run all, it gets to this error cell, and it just stops executing. The error was expected, and that was what I wanted to demonstrate, but it won't run any of the cells after that. So I went and I found this was a known issue, and that I can get around this by installing the Run Tools extension and installing this and configuring this and doing the server. But that means that anyone that I share the notebook with would have to go through all those same steps to get it to work the same way. And so that makes it not really reproducible as an illustration. Okay, notebooks make it easy to teach poorly. Okay, so how many of you have ever seen a Jupyter Notebook tutorial where there's not really much to the tutorial other than pressing Shift-Enter to run one line at a time and get to the bottom, and then you're done with the tutorial? Okay, so I went to the official Jupyter wiki, and they've got a gallery of interesting notebooks. And I thought, if there's a place to find a great tutorial done in Jupyter, surely it's the official Jupyter wiki that has a gallery of interesting notebooks. Here's a Python tutorial. Let's see, what is a Python tutorial that showcases the power of notebooks? Okay, so this is what the tutorial looks like. Let's learn while. While some condition algorithm, executable cell. Break, as the name says, is used to break out of a loop. Executable cell. So this is Shift-Enter, 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 and there's really nothing going on here beyond the fact that the cells are executable. It continues. If you want to learn about if, these are executable cells. Are they a great are they a great way of teaching if and if else? Not to me. Is this a great showcase of what notebooks are capable of? Again, not to me. But this is from the curated collection of Jupyter notebooks that are notable. It was the introductory tutorial. So that's not to say you can't do really nice Jupyter tutorials, but it feels like too often there's this notion of every cell must be runnable, and that's kind of the bulk of what I'm producing. The flip side is that notebooks make it hard for me to teach the way that I want to teach. Okay, so this is from a book, a real book written by me. It's called Data Science from Scratch, available wherever books are sold, second edition being written as we speak. Not exactly as we speak, but as we speak. So several times people have said you should make a notebook version of your book. And I said, okay, sure, let's give it a try. This is the databases chapter, and the book is Data Science from Scratch. So talk about databases. We implement a database from scratch. This involves creating a fairly large class that represents a database. So how do I introduce this class? I say, well, let's introduce a table, and let's introduce the first method, which is insert. Okay, now let's show some examples of how to use this insert functionality. And now let's go back and talk about the next method, which is update. So, I tried to port this over to Notebook, and when I got to the part where I was trying to define the second method, I ran into a problem. And the problem was that I had already defined the class. And so this idea that every cell has to be executable standalone meant that I could not go back and later add new methods to that class, even if that's what I wanted to do pedagogically. And you could say your book shouldn't split the class into multiple pieces like that. That's fair. But the alternative is dumping pages of code at once on the reader and then referring back to it bit by bit. And I personally hate books that do that, and so I made a very deliberate choice not to write my book that way. And I'm not the only one who wants this. I found an issue. People wanted to find a Python class across multiple cells. So other people have desired this as well. One solution is called Jupyter Dynamic Classes. So all you have to do is when you want to add the new method, you just add this %, add to dog or whatever. So that's one solution. Another solution, this was clever, I would not have thought of it myself, is that I define a class with one method, then I redefine the class as a subclass of itself and add the next method, and then I keep doing that. It's clever. I don't think I want to do it in my book, but I like it. This was also suggested, just define the function as kind of a bare function and then assign it to the class. Table update equals update. So every one of these requires presenting unnatural code to my readers just to appease the notebook gods. And I don't want to present unnatural code to my readers. I'm very I try to be very thoughtful about how can I best use code to illustrate these concepts and to teach. And so adding in kind of cruft that's just there for the purpose of making it run in a notebook is not great for me. And that's a complicated example, but here's a simpler example also from my book. I want to motivate when you might want to use a set versus a list. And so I say, imagine you have a list that's stop words, a and that, plus hundreds of other words, plus yet and you. And why you would want to convert it to a set before checking for membership. Now, hopefully, it's clear what's going on here. And I personally think that this would not be improved by forcing me to define hundreds of other words as a variable. And that would actually make the example less clear, because either it would be a short list or I just have a list of hundreds of other words for no reason. So basically, my point is that it's not always the case that having every code snippet executable is the best way to communicate something. But notebooks sort of force you into that format. And that's what I just said. OK, so what do I do instead if I don't use notebooks? Because generally, I don't use notebooks. One is I make Markdown tutorials and docs. So you can see they look a lot like Jupyter notebooks visually, but the snippets are not executable, which is fine because, again, here I'm showing you a function signature. It shouldn't be executable anyway. Below, I'm showing you just the constructor for a class by itself. It also should not be executable anyway. So this is how I write tutorials and docs, and it works pretty well for me. For my actual development stack, I use VS Code and then the IPython console. And I was going to give you a demo of what that looks like, because some people want to know what that looks like. And so I want to, demonstrate logistic regression. So we're going to do logistic regression on some digits. So from scikit-learn, datasets, import load digits. And let's say digits equals load digits. So now, over this side, so let me go into IPython. And what I'll do is I'll just run that file. And when you use the run in the console, it runs through, and it loads all those variables into memory. So now if I say digits, I can inspect it. And data seems to be the arrays. Let me take a step back. What are digits? This is a digit recognition data set. So it's a bunch of 8x8 images of digits with what they're supposed to be. So data is this length 64 array, and target is the correct classes. So I can pull those out. Data equals digits data, and target equals digits target. So now let's go back and run it again. And data, that looks good. What's its shape? Its shape is 1797 by 64. So I want to demonstrate a test and train set. I'll take, say, the first 1500 and split it up that way. So I'll say my X train is data up to 1500, which means that my X test will be data up to or from 1500 on. Similarly, my Y train will be data, or not data, target up to 1500. And my Y test equals target from 1500 on. So that's good. So now I want to do a model. So let's import from sklearn.linear model, import logistic regression. So we'll define a logistic regression model. Model equals logistic regression. And I want to fit the model, fit on X and Y. So that'll be X train and Y train. And then I want to make some predictions. So I'll say predicted equals model.predict on X test. So let's go back and run this again. Check this out and say predicted. OK, so those look like good predictions for what are these digits, 0 to 9. And now let's do some metrics and see how good our predictions are. So from sklearn.metrics import. So I want to do confusion matrix, and I also want to do an accuracy score. So I'll do CM equals confusion matrix, and it will Y true and Y predicted. So Y true is just Y test, and predicted is predicted. And then A is accuracy score, Y test, and predicted. Run it one more time. Accuracy A is 88.8, so that's not terrible. Here's my confusion matrix. That looks good. So that's when it was a 3, how did I predict in 3, and so on. So let's visualize that, 'cause we like visualizing things. So from matplotlib, import pyplot as plt. Okay, and I'm not that good at matplotlib, so we'll see if I get this right. So fig ax equals plt dot subplots, and then unfortunately that's not typed, so I don't get good types on those. So ax dot mat show the confusion matrix, and I want to make a color bar with that, so I'll do this, and then I'll say fig dot color bar, and then fig dot save fig, and let's call it sklearn.png. So if I run it again, let's see if it works. So here's sklearn.png. So that looks pretty good, but I would have liked to have done a title on it. So let me go back and add a title, fig.subtitle, confusion. And now I can run it again, and if I go here, now it's got a title on it, and I can proceed in that way. So you're thinking this was possibly a lot more clunky and confusing than using a notebook, and possibly it was, and the whole saving your plot in a different tab and having to look at it is not great. Where it's nice is, okay, now I want to start factoring some of this code out so I can test it and reuse it. So let's do load data, file name, string is none, and this will be a tuple of numpy array and numpy array. So I've just used some types that I don't really have, so I better import them. Import numpy as np, and then from typing import tuple, so that'll be good. And now I'll just put all this inside a function and return data and targets. Okay, so now I've got this inside a function, and what I can do is I can go over and write a test for it. So I want to test that load data works, so I'll say data target equals load data, and now I can assert that data.shape equals 1797.64, which I think is what it was. And now I can run pytest. Named data is not defined. So I already broke it. Let's see. Yep. Data target equals load data. Good. So, and now my test passes. And so the virtue of doing this, apart from being able to work in my text editor, which I really appreciate, is that now I can start factoring all these different pieces out into functions. I can test them, I can reuse them, and I don't have to rewrite everything from the beginning each time. I promised that I would give you a chance to win me over, so here's how you could win me over. So one is the Jake plan. Jupyter Notebooks could have a reproducibility mode where code cells are read-only once executed, new code cells cannot be inserted above previously executed cells, and no cell can be executed until previous cells are executed. So this is sort of how physical lab notebooks work. When you're doing science and keeping results in a physical lab notebook, you can't go back and cross off the observations from yesterday and write new observations on top of them. You have to keep going in order. So something like this would alleviate a lot of my complaints, but I also suspect that a lot of people would hate this workflow. I could be wrong, but that's my suspicion. You could force people to name new notebooks. That's really simple, but I think it would be a good idea. You could give me, like I said, IDA style autocomplete. I really rely on it for my coding, and it's very tough for me to code without it. And it's the sort of thing where if you're not used to using it, it can be hard to appreciate how much easier it makes your life, but it makes my life a lot easier. Some kind of real type checking and linting, I also rely on that a lot to write good code. And so if there were a way to offer that, that would be much appreciated. Definitely a better story around dependency management. Even non-notebook Python has a huge problem with this, so notebooks are not alone in this regard, but if there were a way that notebooks could step up and say, here's a great way to manage your dependencies, that would be, I think, really helpful for reproducibility, extensibility, and things like that. And then, first-class support of refactoring code out of notebooks into modules. Notebooks are good for experimenting with things, but like in the long run, I firmly believe you want your code in modules, you want unit tests on it, you want to be able to reuse it between projects, you want all these things. And so the easier it is to get your code out and into a module, the better it is. Now, the reality is you're not going to provide me all these things, and I'm not going to switch to notebooks. But I hope that I've challenged you to think about, one, how your tools limit you, two, how to write better software, three, how to teach better, four, how to practice better science, how different workflows can make your life easier, and some ways that you could make notebooks better. So in conclusion, I hope despite Jeremy's warning that this was not an unhelpful way to spend time, and come to my next talk about how I don't like that slideshow program where sometimes the next slide is right, and sometimes the next slide is down. Can't stand it. Thank you all for coming. So I will tweet out the slides at my Twitter, at Joel Grus, that's right there. Check out my book. There's a new edition coming soon-ish that will be updated to Python 3 and have some good stuff in it. My blog is very infrequently updated, but it's there. I have a podcast. I make live coding videos. You can send me an email and tell me why I'm wrong. And like everyone else on the internet, I have a SoundCloud, which you can check out and see my stupid little experiments in music composition. So I'm happy to take questions, heckling, feedback. I'll check it out.
Something that I think may be underlying a lot of this is there is such an unacknowledged tension in the world of notebooks between, is this a messing around with, playing with interface, or is it a publication interface, right? And the two are fundamentally at odds, which I think is something you've identified here, right? The publication interface does not match the exploratory interface at all. And so I have no idea what, if anything, to do about that, but yeah, if you're playing around with it, then you lose all the benefits of the important stuff.
Yeah.
It's just related to that one. So then what do you think notebooks are good for? I mean, you gave out, like, is it just really a good publication format and expect it to be that way?
No, so like I said, I feel like if you really want to explore data, but you explore it in a way where I'm not going back and changing things I already did, but I'm appending to the end, to me that makes it a much more compelling format for exploring data, because I'm not going to get myself in this situation where I've inadvertently changed something I'm relying on, and it's a mystery to me. So that's one use case. I also think they're great for communicating finished results, like you said, that if I have, whether you execute them or not, they're a good format for communicating. So like there's this, this annotated transformer, which I don't know if you've seen. This is sort of in my NLP world. But basically, someone took this really interesting Google paper, Attention's All You Need, and made a notebook presentation of it that's a re-implementation of it in PyTorch, which is easier to understand. But the thing is that most people who are looking at this are not using it as an executable notebook. He did that to make sure that it worked, but this is just a markdown file that people are reading. So I think this is a really nice presentation format, and I think that the notebook probably enabled him to do this much better as this presentation. But I think where it would go awry is if you started, this is a really expensive thing to train on multiple GPUs, and it will train for a day on, God knows how much data. And so you don't need to tell people you can shift enter and run this cell and shift enter and run this cell. It's really, I'm using the code to illustrate how to do this without making it so you need to run each little piece.
So with that example you talked about with like teaching and having to break up the class definition.
Yep.
So, would a possible solution be like, imagine if you could somehow more or less invisibly give a reader mark those cells as joined, like when you execute one, you execute them all in order. Would that be, like a solution, or would you still be like a conflict with just the way it, or like with the way you have to still break up the code seem unnatural to you?
So if you had to like mark it somehow that was transparent to, it's an interesting question.
Some metadata, or maybe you could like click a button on the margin or something like that.
So there's I have two thoughts about that. One is that it would be reasonable, and possibly this is even the case, that if a cell like starts off indented and it matches the indentation of the previous cell, that it just continues it. That wouldn't actually address this case, because the way that it's done in the book is I'm going to introduce a class and one method. Now I'm going to show you some instances of how to use that method, and now I'm going to go back and indent again. So it's almost as if you have this nonlinear thing where one thing branches off, but then the execution continues down. So it's pretty complicated. I think it would be tricky to get it right in a way that doesn't make the notebook really hard to understand or make it seem kind of magical. But I don't know. I haven't thought much of. Like I got to the point where I'm like, this doesn't support like the flow I used in my book, and I didn't get much beyond how I would make that work.
I loved your book. I loved the talk too, actually, and a lot of it I agree with. The one concern I have is it's very much an all or nothing talk, and I think in practice, the way I've used the notebooks have not been all or nothing. I think you need to have sound engineering principles behind how you're presenting information. For example, the example that had the minimalist notebook trying to teach Python, we've very effectively in San Diego used a minimalist notebook to teach Python since 2013. However, we have 3 people teaching, one who is reading the notebook, one who is executing code in the REPL, and the notebook is the takeaway for the audience. So they're doing it in the REPL. So I don't think it's an all or nothing.
So I agree with that, and I think there's plenty of ways to use notebooks that are actually quite helpful. I would say my position is more. There are a lot of ways to use them that are unhelpful, and a lot of people gravitate towards those ways or build tools to help facilitate those ways, and I consider that kind of dangerous.
And I completely agree with that. And having PyTest notebooks, which like Tim's suggestion, try hydrogen. We're getting much closer to the things that we want as like Python core developers or whatever. So your points are well taken.
So I agree with all the points. In principle, one of the things I've observed with people using notebooks is they're kind of like a gateway drug to coding. If coding is this intimidating thing for non-technical people, how do you get them to try little chunks of it and see that it's not threatening, it's not going to like make them feel like idiots? So I see value in that, but yeah, there has to be a better way of ramping them up to cover engineering and methodology and so forth. But it lets them put their toes in the water without, causing things to go awry or causing supercomputers to explode. So that's just my perspective on it. But
I think that's fair, and like I said, I think that if that's the use case you're optimizing for, there are things you can do that make them kind of a safer way of exploring coding, and so just not letting you go back and change cells that you've already run, that would make it that would allow beginners to code with I think a lot fewer problems, for instance.
Just like as a side note, if you or if anybody else wants to directly influence the future of Jupyter, right now there's user testing going on just a couple doors down, and you want more people to go do it. So go do user testing. It's open all day.
Right.
Yay, it's not called.
Is there someone else over there?
I was just going to mention that the gateway drug thing. I've run into students who also find the Jupyter interface pretty intimidating. And I also want to give a shout out. I'm not affiliated in any way to REPL.it, which is sort of the web browser based text editor.
Yep.
I just was curious if you had a take on other approaches to more literate programming, because it feels like you were arguing for something like You're sort of doing duplication that.
So I don't have a great approach. I've thought about this a little bit, and I think my ideal would be, so like on LNLP we use Sphinx, so you write up docs for your classes in the Sphinx format, and if you're lucky it converts them to docs. And if you're unlucky, it gives you a cryptic error message that you forgot to put a new line somewhere, and it takes you an hour to figure it out. And so I feel like there's a way that if you put your doc strings or your code comments in some, markdown-ish format, if you will, you could have a way of browsing code that would render those things nicely and give you kind of a more literate interface to your code. But this is something that I've thought about very little. But something like that would definitely be interesting to me.
Thank you for the presentation. I just wonder what's your take on the approach that some organizations presented yesterday with the paper mill and using notebooks as essentially the log of the tasks.
So I don't think I attended that presentation. I would say that if I understand it correctly, probably my biggest qualm about that is that it's running a notebook and like capturing the output of that inside a notebook and then saving the notebook. To me, having like the output of a process stored in a notebook doesn't feel like a super usable format. Whereas, because then I have to do something to get it out of the notebook, whereas I might want to, run some giant MapReduce queries over the results, or I might want to ingest it into some other system. And so, like, my initial reaction is, wow, that creates an extra layer of complexity at that margin, and that there's something about having, like, I get having notebooks be sort of the source of truth about here's what I ran. It feels a little bit stranger to me to have notebooks be the source of truth about, and here's the output of this process, unless the output is like very small, a few numbers. But I didn't see that talk, so I can't speak super intelligently about it. So would I feel better about that? Which, I haven't used Binder very much. Which of my concerns would that address? Mostly just having an environment with the right dependencies? Yeah, all the dependencies. So that would help with the dependency part. I would still struggle with the fact that all of the parameters for the experiment are kind of all over the place. Some are hard-coded in model instantiation, some are in one cell, some are in another cell. So I have to kind of hunt through the notebook to figure out, okay, here I need to change a path. Okay, in this other place I need to change the number of epochs. Okay, in this other place I need to change the number of hidden layers. And so having not a clear separation between the code and the configuration, that causes me a lot of difficulties as well, and makes it much harder to build on top of it.
So your workflow involves essentially rerunning in IPython your code over and over.
Yep.
And that works when we have a very small amount of data. We have a lot of users who routinely have to analyze dozens of gigs of data.
Yep.
And this is where the short iteration cycle breaks. And where the notebook shines is you keep all the data in memory. So you mentioned earlier, like keeping processed data on a file that you can load. It's actually a good thing because you persist your processed data. But then it slows you down when you have to really reload it. Like, what are your thoughts on that?
So that's a fair concern. And if your intermediate results are 12 gigs of data, then you probably don't want to do the workflow that I showed. But are you talking about doing exploratory data analysis on 12 gig data sets?
Yes.
Interesting.
And that's small data.
What?
That is small data.
No, it's not that it's a big data set. It's a big data set to do. To me, it feels like a big data set to do exploratory data analysis on. But like, I work in a world with pretty small data. So, let me think about that. That's obviously yes. If you have like 12 gigs of intermediate results and you want to rapidly try 20 different things on them, then you're probably stuck either in a notebook or in the REPL, having it in memory and trying things on it. I don't think I have a good solution for rapidly reading gigs of data off disk like that.
I'm more curious about how you would fix the notebook to both satisfy this use case and your concerns.
Oh, so these are immutable data sets. Let's say the intermediate results.
You might want to modify it. You might have a huge data frame where you want to add a column.
That's fine. So I think that the part where you can't go back and change earlier results would help with that a lot still, right? So I've computed this data set. Now I can do various things off it in the notebook, but I can't go back and like change something it depended on or change the data set itself. And if you're asking, what if I want to change that data set itself, then I guess you would have to modify it in place or recreate it. Yeah, okay.
Well, one thing that I don't want to get lost in what's good about notebooks is IPy widgets and being able to build GUIs using pure Python without having to learn another language, and to be able to do interactive explorations, create a slider, rerun analysis. It's not just for plots, or also just create read-only, write-out JavaScript interactive explorations.
Yep, that's fair. I didn't really address that. All right, thank you for coming.